Okay, guys, before I explain what we're going to be doing today, let me just say this. I don't know if I'm going to be able to do a live Zoom session on Wednesday. Um, I've been told that they put me down for a couple of days of testing this week. I don't know what those days are. So not only did they have me, testing last week, they're going to have me testing this week as well. Now she told me she didn't need me all this week, but she did put me down for a couple of days of testing this week. So there's a possibility that I might not be able to do a live Zoom session on Wednesday because I'm going to be giving star EOCs or makeup star EOCs to students. So just be sure you guys are logging into Schoology that morning and looking at the updates because if I want be able to do a live Zoom session, I will post an update um, in Schoology, and I'll just let you guys know what you guys will have to do for that day. Of course, I'll send you to the link to anything if you need to use some sort of outside resource. So just keep that in mind. There might not be a live Zoom session when I see you guys next class period. Okay. Again, it just depends on what days this week she assigned me to testing. Okay. All right. So here's the goal of today. So let me go ahead and share my screen. Okay. So in Schoology, if you click on the folder for today, um, you know what this was supposed to say. Okay, so guys, on today, we're going to be talking about two things. Okay. Um, First thing we're going to talk about vectors. I want to introduce vectors to you all because vectors is something that's very, very important. Um, not only for physics, but also in your math classes as well. And then as soon as I get done introducing vectors, I'm going to explain to you guys the assignment that I have posted, which is called a QQT problem. QQT um, stands for Qualitative Quantitative Translation. And I'm explaining what you guys have to do so that you guys can get that done and then upload it into Schoology. So again, that's the two things we're going to talk about today. We're going to talk about vectors, and we're going to also talk about, and then as soon as we get done talking about vectors, I am going to um, make the assignment available for you guys to be able to submit your QQT problem. Okay, so let's get started with vectors. Now, guys, no, vectors is a very, very important assignment in physics. In fact, a lot of the things that we're going to do next semester will involve you guys having an intimate understanding of vectors. You guys have to understand vectors in order to get into some detailed physics or some detailed physical analysis situations that we're going to look at next semester. Now, uh, guys, if any of you guys plan on majoring in some sort of math or some sort of science related field, you guys will be talking about vectors a lot. In fact, for those of you guys that are in pre calculus right now, guess what? One of the subjects you're going to be talking about in the second semester? Vectors. So, since you guys will be using vectors in your pre calculus class, I highly advise that you guys learn it now. Um, and today, like I said, I just want to give a brief introduction to vectors. We're going to elaborate more on it next semester. I wanted to give a brief introduction to it today. Obviously, just in case I didn't see you guys live on a Zoom call next class period. I want to be sure that I take the time to at least introduce it today so that you guys will see what vectors are before we go out on winter break, seeing that we're going to use it a lot next semester. Okay, so um, what exactly is a vector? Hmm. Before I answer that question, let me show you guys this clip here. So I don't know if you guys have seen the movie Despicable Me, uh, but if you guys have seen Despicable Me, Hopefully you guys remember this scene here from the movie.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah! Check out my new weapon. Piranha gun! Oh, yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Doing a demonstration. Oh, ah! Gosh, it's so difficult sometimes to get the brain back inside of me.
Okay, um, in that video, notice what he said. He said a vector is a mathematical quantity that involves two things, magnitude and direction. So guys, it's very, very important that you guys know that. Those two important things there describe vectors, magnitude and direction. Magnitude and direction. I'm going to repeat that one more time. Magnitude and direction. Those two things explain vectors. So we're going to spend the most of the class period today just kind of explaining to you guys how to draw vectors. In other words, how to represent vectors on a graph. Okay, so again, the main topic for today is vectors. And again, like I said, I just want to introduce this to you guys because next semester we're going to be using vectors a lot. Vectors are important. Vector is a mathematical quantity represented by two things, magnitude and direction. Now, guys, suppose I give you these two numbers right here. 3, -5, and I ask you guys to draw out the vector that is represented by these numerical values. How would you do that? Okay, first of all, before I draw out this vector, I'm going to say this here, guys. Anytime you see two numbers in this class and also in any other math class that looks like this, where it's it's represented by these angled brackets, that means that that means that we are representing a vector. Okay, so and obviously you would draw your vector on your coordinate system. Now, up until this point in your algebra class, you guys are used to labeling points. So, for example, let's just say you see something like this, -3, 3, -5, and it looks like this. Guys, this means a point on a coordinate system. This right here means a vector on a coordinate system. So just so you guys know the difference in notation, if you see your two numbers in parentheses, that means a point on a coordinate system. If you see your number in angled brackets, that means a vector on a coordinate system. So just keep that in mind. Recognize the difference between a point and a vector. Okay. So with that said, let us draw this vector here. Okay. So, guys, in this class, all of our vectors will have an x component and a y component. Okay. So we have an x component to this vector and a y component to a vector. Okay. And guys, remember what I said, a vector is represented by an arrow. So how do we draw vectors? Well, let me draw my first vector here for you guys so you guys can understand how to draw vectors. Okay. So whenever you're drawing a vector, guys, you can start drawing your vector anywhere you want on your coordinate system, anywhere you want. I'm going to start by drawing my vector here, right, this point right here. So what this is saying is, whenever I'm starting to draw my vector, what this is saying is I want to go 3 units in the positive x direction. Hold on, guys. Let me start over. Let me make sure my color is right. So, okay, let's assume that I start at this point right here. I want to go 3 units in the positive x direction. And then from there, I want to go 5 units down in the y direction. So 1, 2, 3, 4, 5. Okay, so everybody see what I did? I went 3 units to the right and then 5 units down. So this was my starting point. This was my stopping point. Whenever you draw your vectors, guys, this is how you draw your vectors. You always draw your vectors pointed away from the starting point toward the ending point. Okay. So guys, this arrow here that I just drew in red, that is the vector 3, -5. And that's it. That's how you draw vectors. Okay, it's that easy. Let us do another example. The more examples we do, the better. Okay. So remember what I said. Whenever you're drawing vectors, you can start by drawing them anywhere you want on your coordinate system. Okay. Suppose I want to draw the vector. Suppose I want to draw the vector 6, +5. How would this vector look like right here if I had to draw that vector? Okay, so remember, all vectors all vectors in this class have an x component and a y component. Okay, so what this is saying is whenever I'm drawing my vector, I want to move 6 units to the right, and then I want to go 5 units up. Okay, so let's do that. So if I'm drawing my vector, and again, guys, you can start drawing your vector anywhere you want on your coordinate system. Let's say I want to start drawing my vector here. So what I do, I go 6 units to the right. 1, 2, 3, 4, 5, 6. In other words, I'm moving 6 units in the positive direction. And now I'm going to go up because my 5 is positive. So I'm going to go 5 units in the y direction. So 1, 6 units to the right, and then 5 units up. 1, 2, 3, 4, 5. Okay. So notice this was my starting point. This was my stopping point. So you always draw your arrow pointed toward the stopping point. Or in other words, pointed toward your ending point. So from start to finish. Well, let me draw this a little bigger. Okay. Like this. So guys, that arrow there in red that I just drew, that is the vector 6, 5. Okay. So that's how you draw the vector 6, 5. And notice what I said, guys, all vectors have magnitude and direction. Okay, you can clearly see that the arrow is pointed in a specific direction. In this case, it's pointed toward the northeast. So that's the direction. And it also has magnitude. Magnitude just refers to how long the vector is. So this arrow has a certain length. So it has magnitude and direction. Okay. Let us do another example. Okay, guys, suppose I wanted you to draw the vector -4, -3. How will we draw this vector? Now here, this is where I want you guys to help me out. Okay. So suppose I want to start drawing my vector here. Remember, you can start drawing your vector anywhere you want on your coordinate system. Okay. So someone tell me, if I'm starting here, whenever I start off moving in the x direction, am I going to move to the left or to the right? Anyone? No?
To the left.
To the left, exactly. We're moving in the negative direction. So I'm going to start here. I'm going to move 1, 2, 3, 4 units to the left. Okay, and stop. And then I need to move 3 units in the y direction. Am I going to move 3 units up or 3 units down? What do y'all think?
Down.
Down. Thank you, Michaela. 3 units down because I'm moving in the negative direction. So 1, 2, 3. Okay. So notice this was my starting point. This was my stopping point. So I went. You always move in your x direction first, then you move in your y direction. So that means my vector looks like this. If I had to draw out this vector, remember the arrow is always pointed from the starting point to the ending point. So basically, you're just connecting those 2 points. So Guys, in red there, that arrow that I just drew in red, that represents the vector -4, -3. Okay? And that's how you draw vectors. It's really that easy. So again, we clearly see that we have magnitude and direction. Magnitude refers to how long the arrow is. And obviously, in this case, the direction is pointed toward the southwest. So vectors have magnitude and direction. Guys, let us do a few more examples because again, I want to be clear that everybody understands how to do these vectors. Okay. Guys, what about this right here? How would I draw the vector 6, -1? So how would I draw this vector?
Go 6 units to the right,
Uh-huh.
and then go 1 unit down.
Exactly. So I'm gonna start here. I'm gonna move 1, 2. Hold on, so let's say I start here. I move 1, 2, 3, 4, 5, 6 units to the right, and you're right, and I will go 1 unit down because I'm moving in the negative direction. So remember, you always draw your arrow. You always draw your arrow from your starting point to your ending point. So this was my starting point, and this was my ending point. So that arrow, guys, that you see in red, that is the vector 6, -1. Okay. Let's do one more, just to be sure everybody's clear on how to do this. Again, vectors represent direction and magnitude. How would I draw this vector right here? -4, +2.
Go 4 to the left and 2 up.
Exactly. You want to go 4 to the left and 2 up. And again, guys, you can start drawing your vector anywhere you want in your coordinate system. So I'm gonna start at this point right here. I'm gonna go 1, 2, 3, 4 units to the left. So remember, always moving your x component first, and then moving your y component after that. So since my 2 is positive, I'm going to go up 2 units up. So I went 4 units in the negative x direction, and I moved 2 units in the positive y direction. So this was my starting point. This was my ending point. The overall arrow should look like this. So guys, that arrow that you see in red, that's the vector -4, 2. Okay. And any questions on how to draw vectors? Okay. That's how you draw vectors. You know what? I'm gonna do one more because I see I had a few people to come on. I want to just do one more, just be sure everybody got this. I know I said I was going to do one more before, but for sure I'll do one more this time. So one more vector. What if I draw the vector 2, 7? So what do I do in this case right here?
You move 2 units to the right and 7 units up.
Yep, 2 to the right, 7 units up. Exactly. So remember, guys, you can start drawing your vector anywhere you want on your coordinate system. So I want to choose this point right here. So I'm going to, so starting here, I'm going to move 2 units to the right, again, because you counted your x direction first. And then I'm going to move 2 units up. And again, I'm moving up because I'm moving in the positive direction. So 1, 2, 3, 4, 5, 6, 7. Okay. So notice, guys, this was my starting point. This was my ending point, right? Because I moved 2 units in the positive direction. Well, in the positive x direction. Then I moved 7 units in the positive y direction. And then remember, your arrow, you're going to connect these 2 points with an arrow, and you always draw your arrow pointed toward your ending point, like that. So guys, this arrow here in red, that represents the vector 2, 7. Okay. All vectors have magnitude and direction. again, in this case, is pointed, toward the north or northeast. And of course, it has magnitude because magnitude refers to how long the vector is. Okay, so guys, that is how you draw vectors. Now, so that just gave you a brief introduction to vectors, which is something, guys, we're going to use a lot next semester. We're going to use vectors a lot. And again, not only in my class, but also when you guys get to pre-calculus, you're going to be using vectors a lot as well in there because vectors, appear all the time in math and science classes. They are very, very useful. Now, so before I explain the QQT, I want to show you guys one way this can be useful because you might be asking, Mr. Taylor, why do I care about drawing a bunch of arrows? Well, guys, it turns out vectors are really useful in physics whenever it comes to describing forces. So, for instance, let me give you an example. Okay, imagine that we have a block here sitting on a table. Okay, everybody already know that as this block sits on this table here, there's two forces acting here. There's the gravitational force. There's a gravitational force pulling this object downward. So everybody know that. But then there's also the normal force from the surface of this table pushing up on this box. There's also the normal force. So there. Okay. And of course, guys, we've already talked about that if we want to know the acceleration of this system here, we just take the sum of the forces acting on this object here divided by the object's mass. Okay. So this is really easy to do. But guys, let me ask you a question. What if you have a situation here in which you have forces that are acting at an angle? So here's what I mean by that. Suppose someone comes along and decides to pull on this box here, so suppose they pull in this direction right here. Okay. So they're pulling at an angle, right? So here the forces were perfectly vertical, but here the force is diagonal. And imagine someone else pulls on the block, but that someone else, they decide to pull in this direction right here, like this. Okay. So suppose we wanted to know the magnitude of this acceleration here, and we also want to know the direction of the acceleration of the box here if you have all these forces acting on it. Well, guys, in order to figure that out, it turns out these arrows here, you're going to need to treat them mathematically as if they are vectors, okay? So that's where vectors are coming in. Vectors really help you whenever you're having forces acting at an angle, because if you can treat these forces, as vectors, meaning you know the x component and you know the y component, you can combine all those components and then go through the math and figure out the magnitude of acceleration of this box here, and also the direction it's going to accelerate in, just by treating these forces as if they are vectors. So this is one way in which vectors is applied in physics. And this is something we're going to elaborate more on next semester when we get to forces acting in two dimensions or acting diagonally, as you guys see here. So I just want to give you guys a little heads up for next semester. This is where vectors become very useful. Any questions on vectors before I explain the assignment on today? Any questions before we move on? Okay, now guys, I want to spend like the next 5 minutes or so explaining to you guys what you have to do for your homework. Okay, now guys, as you guys know, we're in a program called NIMSY, and NIMSY requires me to take a class every week online. So every Wednesday that we meet up, um, um, we have a class. And this Wednesday, I have to present my student samples for my QQT translation problems. Okay, so on today we're going to practice. Well, on today, I'm going to show you guys or introduce to you guys quantitative, qualitative translation problems, and kind of explain why they are important on the AP exam. So give me just a second while I pull this up, and then I'm going to share my screen. Okay. Now, guys, this problem that we're about to do, or the problem that you guys are going to do on your own, what you're going to do, You're going to answer all of these questions here, part A all the way through part E. And then as soon as you guys get done answering the questions, you're going to take a picture of it and you're going to upload it into Schoology. You do not have to write the questions. The only thing you have to do is just write the answers. Um, and of course, if you want to use your own paper, please do so. In fact, you might have to use your own paper because you might have to have enough room to write the answers. Okay. Now, guys, on the AP exam, as you guys know, on the AP exam, there are 5 free response questions. Okay. On every AP exam, at least one of those free response questions involves what is known as a qualitative quantitative translation. Okay, so what that means is, so whenever you guys look at a physics problem, you guys have to be able to describe 2 things. One, you have to be able to explain the physics qualitatively, meaning that, like, can you look at some sort of graph and explain what this graph is telling us in words. Okay, so you got to be able to explain the physics. That's what it means when you're engaging in a qualitative analysis. When you're engaging in a quantitative analysis, that means you can interpret the math, meaning you know how to understand equations. Okay, so there's at least one free response problem on the AP exam every year that is known as a qualitative quantitative translation problem. Okay, now, guys, this qualitative quantitative translation problem, it combines concepts from 2 units, from our kinematics unit and also our dynamics unit. Remember, kinematics was the unit we talked about at the beginning of the school year, when we talked about mathematical motion, and of course dynamics involve forces and Newton's laws and things like that. Okay. So, guys, whenever you guys are working on this problem, you guys are going to have to be able to think back to concepts from the first unit and to be able to answer this question as best as you can. Now, guys, I'm telling you guys right now, if you guys want to get full credit for this assignment, you have to answer all of the parts: part A, part B, part C, um, all the way to part E. Okay. Now, guys, since this is an AP style problem, the most important thing that I'm looking for is you guys are trying your best and you're answering everything in order to get full credit. Um, Now, guys, if you read something and you feel you don't know what the answer is exactly, do your best. Again, on AP problems, you're not expected to know how to do every single thing and answer every single thing correctly. In fact, remember what I said, if you make a 50 on the AP exam, that's enough for you to pass the test. Um, your goal is to do your best and to earn as many points as you can on the actual AP exam. Whenever I'm grading this is a practice problem for the AP test. Whenever I'm grading this, I'm going to give you full credit only if you answer all the parts. So if you leave one of the parts blank, I'm going to take out points. Okay. Now, this assignment here, since this is an AP style problem, this is going to be worth 2 daily grades. Okay, it's worth 2 daily grades, and of course, I'm going to make the due date not midnight tonight, but tomorrow midnight. So, guys, be sure you have your answers uploaded into Schoology by tomorrow midnight. Um, and of course, guys, they definitely have to begin by tomorrow midnight because I have to have I have to have some student samples ready to present for my NIMSY class on Wednesday because NIMSY is requiring us to give these problems to you guys in a very narrow window. Because again, I have to present for my class because of my teacher can grade me on my students' work. Okay, so be sure you guys have it done and uploaded by tomorrow midnight. Okay. Um, Let me read this real quickly to just kind of get you guys started. It says, um, students are working in the laboratory. They have a motion detector, a cart, a stiff hoop spring connected to a force sensor. The students decide to keep the mass of the cart constant throughout the whole experiment. The students then collect data and take snapshots of various velocities versus time graphs. They notice that with each trial run, each time they vary the compression of the spring, therefore varying the force acting on the cart, the slope of the graph continuously changes. Several experiments show that each time the spring is compressed more and more, the steeper the slope of the graph becomes. The students then write down the following equation in an attempt to explain the data they obtain. So the students write down this equation. They said the slope is equal to mass divided by force. Is the above equation accurate? If not, explain why. Okay, so now let me explain to you guys how this setup looks like, because normally during a normal school year, whenever we're in the laboratory, we work with motion detectors, carts, and force sensors. But let me just show that to you guys, how that looks like, just so you guys can have an idea of what the question is saying. So let me come over here, okay, and let me show you guys the setup. So, I'm gonna put my camera here. Okay, okay, so hopefully you guys can see this here. Um, what I have here, I have like this is what is known as a hoop spring. Okay, so it's a spring, and it's connected here to a force sensor, and of course I have a cart here that I'm able to roll on the track. Okay, so as you guys can see, as I compress the hoop spring, notice it applies a force on the cart, and the cart moves in that direction. So what that question is saying is that the more and more you compress the spring, the greater the force is acting on the cart, and so the greater the slope of the velocity versus time graph. Okay. Right here, I have a motion detector, and motion detectors uses sound waves to kind of plot out the motion of this cart here, and to produce a velocity versus time graph. So this is what the setup looks like. So it just looks like something like this, where you have a hoop spring, and again, as you change the compression, you can actually read out the force being applied on the cart. So, if you compress it a lot, obviously you get a huge force. Okay, so of course you see just kind of bouncing off the springs. So that's the basic idea behind the setup, where again you're increasing the force acting on the cart, which then causes the slope of the velocity time graph to change. Okay. And of course, one of the things I'm going to do, guys, I'm going to use my uh, I'm gonna use the camera on my phone to kind of get a close up of that setup, and I'm gonna put it on YouTube so that in case you guys need to go back and look at that again, whenever you guys are working on the assignment, you can do that. Okay. Now, remember what I said, guys. You're not so much concerned with getting everything 100% correct. In fact, I completely understand if you guys don't get everything 100% right. I mean, it'd be great if you do, but hey, the most important thing that I'm looking for, and the people at NIMSY are looking for, and also the people who grade the AP exam, they're looking through your thought processes. Are you able to read through this scenario, use the information that you've already learned, and are you able to think critically to answer these questions? Okay, so do your best, guys. If you do your best, I'm going to give you full credit for the assignment. And of course, um, um, whenever we have a class period, I can actually go over the rubric for how this is graded. Okay, but do your best. Remember, you're gonna show me your work. Again, you don't have to write the questions. Just write out your answers. Think critically, and upload it into Schoology. And this assignment right here is worth 2 daily grades. Okay. Any questions on the assignment before I let you guys go? Okay. Yes.
Mr. Taylor,
Yes.
I've been driving, but I've been listening at the same time. But can you not mark me absent?
Okay. Hold on, Tion. Let me write your name down.
Okay. There isn't a form.
There is, but she says she's driving, which means she can't fill it out. Yeah. Huh? Do you need for me to put it in the chat box for you, Jermaine? All right, guys, you're free to go.